All right, hello everyone. This is El Profe Lo, and in this video, we're just going to focus a little bit more on vector addition and the general concept and how we can play with vector addition. Okay, so we have this diagram, and it gives us these different directional vectors, and it gives us this information as well as this additional information, right? And we have vector addition that we're going to look for each of these particular problems. So if I want to find vector AC or find a relationship that deals with vector AC, a way that I can end up, right, if I want to say, how do I end up with that vector, right, by starting at this point, well, what I could do is travel to O, and then from O, travel to C, right? And so I could say that A to C with vector addition is going to be A to O plus O to C. Okay. And when I'm doing this vector addition, I need these interior pieces, right? The head of this to match the tail of that vector, right? The head of this vector to match the tail of that vector. I need these to be in the middle, and that's going to set up my canceling. Okay. If I had for vector O to N, right? So vector O to N is not shown, but if I say I want to figure out how to get that vector O to N as a result, there are several ways that I could do it, but I need to start at vector O, right? And I could say a number of things. I could either say, hey, that O to A plus A to N is going to be equal to my vector, right? But also I could think in other ways. I could say, you know what, that if I have A to O plus O to N, that would equal A to N, right? So there's different ways that you can set up this equation, but what matters is that those interior pieces match up. Okay, and for A to B, for vector A to B, so I've got this vector from A to B, all right, so going in that direction, the vector from A to B, I could say that that vector from A to B is going to be the result of going from A to O plus O to B. Now, of course, I could have said A to C and then C back to B. There's a lot of different things that I could do, but this is just a general idea on how to approach it. There's not just one way, okay? So A to O plus O to C. What does that equal? Well, A to O is going to be opposite of O to A, so opposite of 3P, and opposite of 3P would be negative 3P. And O to C is 4 times O to B, so that's going to be plus 4 times 3 cubed. And so that means I am going to have 12Q minus 3P as vector AC. Okay. And if I was going to be working with ON, well, O to A, right? O to A is 3P. A to N is 1/3 of AC. AC is given by this, so I'm going to have plus 1/3 of 12Q minus 3P, right? So 1/3 of this, that's going to be 3P plus 4Q minus 1P, and that would give me then 4Q plus 2P as my result. Okay, and that would be vector O to N. All right, and if I wanted to figure out A to B in terms of these, right? Well, A to B is going to be A to O. A to O is negative 3P. O to B is 3Q. And that is simply the answer. It's already in terms of A and, excuse me, already in terms of P and Q, right? So you do have to make sure you mind your P's and Q's. And there are different ways that you could set these up. But when you're finding these vectors using vector addition, the formula used in the substitutions must be shown. Okay. This is El Profelo. As always, if you have questions, please reach out.